All right, let's go ahead and begin. So hello, everybody, and welcome to today's webinar presentation, Discover, Deliver, and Secure Your APIs Anywhere, brought to you by Volterra. I would like to introduce you to our presenters. First, Pranav Dharwadkar, VP of Products. Pranav is a VP of Products at Volterra. Previously, he led connected car products at Jasper, acquired by Cisco. Pranav's connected car products used by Tesla, GM, and Ford won the GSMA GLOMO Award. At PayPal, Pranav drove several percentage points improvements in the checkout conversation rate for its core checkout product. At Cisco, Pranav led acquisitions for the collaboration group and led product management for the $1 billion core routing product portfolio. He has 6 patents, and his research is published in the IEEE Distributed Computing and Infocom. And then for our second presenter today, we have Jakub Pavlik, who is the Director of Engineering at Volterra. Jakub is the co-founder, former CTO, and chief architect of TCP Cloud. Jakub and his team worked several years on the IaaS cloud platform based on OpenStack Salt, Kubernetes, and Open Contrail projects, which they deployed and operated for global large service providers. Currently, he works as the Director of Engineering at Volterra, where he's building cloud services for modern applications using Istio and Kubernetes. And at this time, I'd like to pass it off to the both of you for the webinar presentation.
Thank you, Drew. All right, so today Jakub and I will talk about the 4 key tenets that users need to look for in any solution that protects their apps and APIs. The 4 key tenets are: how do you discover, analyze, secure your APIs anywhere? The needs for modern applications are changing. Last decade, it was all about hybrid cloud, moving from the private cloud to the public cloud. What we're going to see next is, not only once you've adopted one public cloud like AWS, now you want to look at how do I adopt multiple public clouds, Azure, GCP, for multiple reasons. One is best of breed of services from each cloud. Second is actually get a better price from multiple cloud providers and keep them on their toes. The third big transformation that we're seeing is, not only are users deploying their applications in multiple clouds, they're actually also deploying applications on the edge, where the edge could be a manufacturing facility close to a machine for operational efficiency reasons, could be in a retail store for AI camera use cases, as well as in the nomadic edge, like a charging station, or even a robot, or even a car. Similarly, the application architectures are changing. They're going from monolithic applications, which in the previous decade were all virtualized, into virtual machines. But what we're seeing is, now there are newer application architectures like microservices, like serverless, which significantly impact how these applications are actually architected. The security and networking paradigms that work for virtualized applications, VM based, no longer apply to microservices based applications, because earlier all of these virtual machine based applications were all the networking security was done at a at an IP address level, right? So because these applications were not as ephemeral. But what has changed is that these once these applications move to microservices, move to API based, everything is addressed by an API. A network level construct like an IP address does not work. These applications are ephemeral. They keep dying and restarting. So the IP address changes constantly. Meanwhile, the segmentation and security constructs at a network port level do not work because all of the communication of APIs is multiplexed on the same port, which is 443. So the network level security and connectivity constructs do not work in this new world of modern applications. And what this results in is application and API security challenges, which are not solved by the current tools. If you look at the current WAF tools for application security, they essentially protect against the top 10 OWASP web security attacks, such as SQL injection, cross-site scripting, or XML external entities. But these tools do not protect against API level security attacks, which is essentially characterized by excessive data exposure, where your app is exposing a lot of data, which it should not. B, it's exposing probably PII data, which it should not. Then these APIs are probably not authorized to share data with the right client. Does the client have the right permissions to even access the data being shared? And then in many cases, it doesn't protect against other API security attacks where there's a lack of rate limiting or lack of resources. So to protect against these app to app and API to API security challenges for modern apps, we require a brand new approach, which is focused on app to app and API to API security. Let's take 3 real world examples that have happened in the recent past to highlight this. Just last week, Waze, there was an API vulnerability that essentially exposed PII data. So as users drive on the highway, they can report obstacles or accidents and so forth. That API where users are reporting, hey, at this latitude, longitude, there was or this location, there was an accident. That API returns back an internal user ID, which is a PII data. And then there's another API where we could send the internal user ID and it would get by the username. So a white hat hacker named Peter Gesper actually used this information to build an essentially a hotspot map where he could track users and find out their real location. So their personal identity and address was revealed using these API vulnerabilities. The two root causes is one, a WAF would not protect against this because this is a legitimate request. There's no blocking. There's nothing malicious here. The bigger problem was the internal user ID should not have been sent in the API response. This was probably a construct that was in the dev pipeline and somehow made it to production. The week before that, a dating app API essentially allowed a complete takeover of the user's account. So in this dating app, where users could essentially click to reset their password by providing an email address, that API, in the API response, they actually sent back this password reset token, the temporary password, right in the API response. So me as a hacker, I didn't have to even have access to your email. I just had to go click password reset, give anyone's email, and I would get the temporary password, and I could then go ahead and log in and take over your account, your dating profile account. Again, here, a WAF would not protect against this because this is a legitimate API request and response. The problem is the data being shared, which is PII, which is a temporary password, should never have been sent in an API response. The third example, in June, there was a Starbucks API that actually exposed 100 million customer records. This was done using Starbucks' gift card API, where users can check the balance of their gift card from their app by using the API. So the gift card API actually does a request to this backend for frontend, which essentially replays all of the requests coming from the app to the BFF, which replaces it to the origin server. What happened was again, this was a white hat hacker named Sam who found out that that essentially by appending this request pattern of dot dot slash dot, which is essentially traversing the directory tree, he was able to bypass the WAF. And after bypassing the WAF, he found out that this BFF actually was able to talk to a Microsoft Graph service, which essentially had all of the 100 million customer records. So by just using a simple public API, a GET request, he was able to access 100 million customer records using a public API. Now let's dive into the root causes. First, this is Microsoft Graph Service is an important thing. This is your address book, or this is your list of all your accounts. A BFF, a front-end service, should never have been allowed to talk to such an important service. Number one, right? Second thing is the WAF was easily bypassed using this pattern, and the API gateway did not detect this unusual pattern, which has never been used before, right? And the third thing is there was no blocking of an API response that is actually exfiltrating 100 million records, seeing some patterns to say this has never happened and we should be blocking this. So if you hopefully what these examples are showing you is that your traditional tools, these are all legitimate requests and responses, your traditional tools will not catch this. You need something that is focused on application and API to API. By the way, these security vulnerabilities are not only in just the cloud or in e-commerce websites, they're also on the edge. In February 2018, Samsung and Roku TVs, they reported that it was vulnerable to hacking because the API was assuming that the person calling the API was authenticated. So it was allowed to talk to the Samsung SmartThings server. But if I just knew your device ID, which is there on the TV or is there on the box, I could actually use the API to talk to your TV and change your channel. Same thing with the gym management app, which actually exposed info for thousands of users. Same thing with the Grandstream modem or router, where people could steal the pre-shared key, the SSID and the key for 1 million Wi-Fi hotspot routers. The same problem also existed in a Mercedes-Benz, where someone could take control of a Mercedes-Benz remotely. This was reported in August 20. And then just recently, a fashion retailer in Europe also reported a massive data breach of 1 terabyte of data using these API vulnerabilities. If I take a step back and just seeing from all these examples, what are the key security challenges that you can see from?
So it looks like we're having just a bit of a technical difficulty with one of our presenters. Let's see if we can give him a minute to get back online. And if not, we will continue moving forward with Jakob. All right, well, it looks like he is not back online yet. With that being said, Jakob, are you, if I give you presenter controls, are you able to move forward? Or would you like to wait a second?
We can, I can take it probably. Okay, so if he comes, please let me know. So, so basically when Pranav ended up with the key API security challenges with those examples, so just to summarize, basically what you can see on those examples is that traditional WAF, web application firewall, cannot protect you against some of the requests which are legitimate, and therefore it cannot be blocked, and usually it's caused by issue of in the code caused by engineer. So Starbucks didn't know which service was talking to which service, dating up didn't know which data are actually being shared by the APIs. Vase didn't know about personal identification data being shared by other APIs. And Gym app didn't know the correct threshold values for the limiting. So you can see that these are the various challenges which cannot be really catched by WAF. Therefore, there is opening a space for a new approach which needs to really be handled on the API level, on the API communication, and it's not enough to just take a firewall, load balancer, WAF, but it requires really to be focused on the app-to-app and API-to-API security service stack. So basically, what is needed is to be able to discover API. So run your app and see which are actually points and applications who talk to each other, and what are the API endpoints. So basically what they are talking to. Then analyze it. So when you know how application communicates and through which API, you can go and analyze actually what they are talking to, like what content, what are the schema in the requests, what are the required fields, what are the type of data, and this kind of information, which can then help you to secure those APIs and find the patterns, find the regex values, how you can actually secure and block malicious traffic or mistakes of the developers in the API. And the last point, which is very important, is it has to be able to deploy it anywhere, not in just public cloud, but you should be able to guarantee it in on-premises, public cloud, private cloud, or the edge. So to summarize, before we will go to the demonstration and I will show you the real demo, app-to-app and API security focus solution needs to focus really on the following. Discover, so who is talking to who and how much and when, so what's your rate, what are the endpoints which talking to other and similar. Then you should be able to analyze it. So basically, what is your normal communication pattern? Are there any anomalies in the traffic? What request rates are normal? What response size are normal? So you can, if you have a simple API and there are coming two size of request in 90% cases, then if you suddenly receive much bigger request, then you should be able to see that it's an anomaly and it's not something which is common, and you should take a look and block such a request or analyze why it happened. And then secure, what signature should I use to block my PI data exposure? So it's not only about to find PI data, but also ability to block it. What does a malicious API request pattern look like? Or how can I apply actually those policies automatically? And this is what I'm going to show you in the demo shortly, how we can automatically apply all those policies. And last, as I mentioned, uniform it and be able to run it across DC cloud or the edge. Now, let me come to the second part, which will be demonstration. I hope Pranav will join us meantime, and he will be able to answer some questions and also help with some explanations. So what we get ready for today is we took an application, microservices application called Hipster Shop. Hipster Shop is an online boutique application developed by Google as an example microservice. So what you see here is AWS VPC, where we run our Vault Mesh, which is our egress gateway, and we run few services: front end, currency service, checkout service, product catalog, recommendation service. So we run few of the services, and they talk to each other, and it's a real microservice setup. Total of nine services, and all this we are exposing on the global network. So if I zoom out, now you can see we have US East region AWS with ingress egress gateway, and this is connected to Volterra global network. And in our global network, we are exposing the API and the e-boutique on the public network. So what I want to demonstrate as a first is a DevOps and SecOps discovery, up to app, and API to API communication. So when visitors are coming over their browser, they are actually hitting our global Anycast backbone, and that traffic is routed to the right AWS region. And what we are storing is metrics and logs. So we collect the metrics for the up-to-app communication and logs for the API to API. Those logs are sent to our SaaS service on the public API, and we are able to then, based on this, build the service mesh graph based on metrics, and also build the API usage graph. So from the metrics, we see which application instances and microservices talk to each other. And from the logs, we are able to build the API communication graph and show it. So this is the first demo what I want to show you. So let's jump here. So what I have here exposed is application called Hipster Shop. It's on the public endpoint, advertised on the global network, and it's a simple e-commerce where you can add items into cart, and then when you add it into cart, you can actually fill the checkout and place the order, and you can order the complete. It has a recommendation service and other components. So very simple, like e-commerce page, and this is served in Volterra. So if I go here, if we log in inside, we can actually see on the map that currently I am having my AWS site running in the North America, and this is the site which is serving the e-commerce shop. So I see some basic information like requests and errors, and this is the ingress egress gateway in AWS. If I look at app traffic, I can actually see we have also backup in the Azure in this case, but what you can see here is how traffic from the public network is flowing over our global network, London, Paris, into the AWS. So we actually see on the network infrastructure level how traffic is flowing. So this is the infra level. Then if I move to the service mesh in the Hipster Shop, we can actually see, and this is what I mentioned. So this is based on metrics, and this is the up to app. So we actually see, can even put last 24 hours. We can see how front end is talking to shipping service and recommendation service and checkout service. So we are automatically getting the entire topology, and we can see individual microservices like requests and errors. So this is the discovery part, what I was mentioning. And this is up-to-up communication. Now, if I move to API endpoints, this is API to API, which I was also explaining, where you can actually see entire tree of API of our microservice, and the size is proportional based on percentage of the request. So for instance, I'm able to see that on the main page there is 98% request, then 55% goes to hipster shop currency service, and then we can actually like do this, right, and see only that 21% is going to product catalog and 55% goes to currency service, and then convert and get support currency, and we can see like an entire tree of our application, and this is all dynamically discovered just by running the application. I have also some other information which I'm able to see, and the metrics. So this is what you see here is basically discover part of our app, where I show you just by running application inside what we are able to visualize from the logs and metrics. Now, when I do the discover part, this is the summary. So you saw up-to-up communication graph and API to API communication graph. So when I do the discover part, I can actually move to the next phase, which is the analyze. And analyze will help me to basically see the baseline for the normal up-to-up and API to API patterns. And using our machine learning models and time series analysis, we are able to actually analyze the string classification and structural properties of the individual request in the graph analysis, and we can see actually what those apps APIs talking to, and we are able to recognize PII data which are flowing through the API automatically through the machine learning just by collecting logs. So now let me show you this part where I can analyze patterns and data in the API. So first, what I will show you is I will show you the metric data. So if we check our front-end service and we will go on the metrics, we are able to see the request rate. What is the current request rate from the metrics on the front-end main page? And this light blue is showing actually confidence interval, which is calculated, and it's telling you where the request rate should actually land in the normal situation. But if we move in the time, actually here, we can see the anomaly. So this is how we are able to display anomaly in the traffic. And you can see that there were time when actually traffic really bump up request rate, and it crossed the confidence interval what we calculated. And this is how we are able to see the anomaly and get to know something is wrong. And we are able to send alert, for instance. You can get the alert, or you can do more things, which I will show in the next phase when we will actually do the securing of the API. So this is based on metrics. Now, this is up-to-up request rate. We can move back on the API endpoints and see individual APIs. And what is interesting is, for instance, a checkout endpoint. So we are looking at cart checkout. So if we go back here, you can actually see when we do place order, you can see this is the API cart checkout. And we are getting probability distribution functions automatically calculated. So we see it's a post method, and we can actually see a request size. And what this is telling us is that with 96 percentage probability, the request size on this endpoint will be 0.67 kilobytes. So if I will receive different size than 0.67 kilobytes, like let's say 0.8, I can be quite sure that something is wrong and behavior is not normal, and I can behave accordingly. Again, I can do the alert, or I can create a rule to block such a request site. So this helps me to really identify what are the normal sizes and what are expected request sizes which will land on my particular API. If we go back, one more interesting thing is the section PII, like personal identification information, where just from the running applications for few hours, our system and machine learning is able to identify that in that API is actually PII data, which is email, which is personal email. And if we go back to the application, we can actually see that email address is here. And if I jump back, we are not going to getting PII data, but we are actually getting a whole schema. What I mean by that is that we are actually able to produce Swagger schema, and we are able to give you documentation on what is actually required on your API. So here you can see that the required fields on the API is the credit card, CVV, email, city, street address, zip code. So if I go back, you can see that this is exactly what we see here. If I do the inspect, and we will place the order, you can actually see form data here in the request body. And if we compare it with our learning mechanism, we see these data are required. And not just that, we are also getting the patterns, basically patterns which are happening, and we are able to then block those patterns and help you to stop it. So in this case, we see there is credit card CVV. This is also something which should not flow like this. And if you look at example, this is the example on the API, one of the example. The reason why it's 0 is because we are automatically removing and reducting the values related to credit cards, because that cannot go into display. So we are immediately reducting. We are able to identify credit card information and reducted it from the logs. But you can see the example here, which was pasted a few times, and the length schema. So this can help you with few things. One thing is you actually get to know what is there, so you can get documentation on the, if you have legacy app, you don't know what's your API. If we give you the Swagger of your API just by running the app, it's I think quite cool. And what's more, you can block the requests what you are not interested in. So if I jump back to our presentation, so this is what you saw. I show you how in Analyze, I show you how you can see the anomalies in the metrics up-to-app communication, and I show you also how request and response pattern in API to API behaves. Plus, I show you that we are able to learn the schema and determine data shared by APIs, identify PI data which are shared with examples, and then the last one, which will be very important in the last demo, is how we are able to actually determine the patterns, which can then help you in the securing the API. So how actually we can secure the access, the last point. So we did the discovery, we analyzed the traffic. Now we see there is an issue. So we want to secure it and we want to block it. So we have a DevOps team and SecOps team, and the goal is to make it secure, but still dynamic development without very complicated process of configuring firewalls or network or security devices. So first, we can automatically generate policy based on up-to-app and API to graph. So we can actually create policy which allows only things which should talk to each other to let them talk. And we can apply it, we can learn it, for instance, on the staging environment and apply it to production. That is easily to do. We create a policy, service policy, to block API response based on pattern what we learn. So we can block it, block size or block the PI data, anything like this. And we can block also API requests based on probability distribution function of the request tree. So now let me show you. If I go here, I have service policy set is empty. So we have a service policies, and you can see there is no except these policy rules, but you can see that it's almost empty. The service policies what you see are shared. They are not created inside of this namespace, but you can see that those are some built-in policy rules. So now I could go and I could create policies one by one. But what we have something, we have tool which we call Ninja Cattle, and he is actually just talking to our API. And I can just say, please API discover last 24 hours in my namespace hipster shop. And what you can see is actually who is the client, who is the server, what is the method, and what is the URL. And this is just based on last 24 hours communication pattern. So this is just the same content what we saw in the visualization, what I show you. This is just driven through API. And now I will just call Ninja Cattle control, which will take all these things which were learned, and he will create service policies and policy set for me. So let's do it. Or maybe one more thing, just to show you before I do it. You can see that now, when I hit some URL, like card free, for instance, it doesn't exist. So application is returning not found, right? This is just before I apply the policies. Now I will apply the policies. So it will take what it learned and just produce the service policies. We can actually go and verify. So if I just do service policies, you can see that now card service, checkout service. So I just created all these policies through CLI because it's faster. We have a new policy set called hipster shop, and we have many rules which are generated based on the learning, and we only allow what is allowed. So now if I actually refresh this, you can see that instead of not found, I am getting forbidden, because we are allowing only endpoints which were learned and which should communicate, and not endpoints which not everything. So if you remember the Starbucks case when they had like slash something and there was bug, this would never happen if they would use this for the service policy, because they would get 403. However, the main page still works. So just to summarize, we went into what we did. Our CLI tool was that he just went and he took the information from API about this topology, about these endpoints, and then we enforced all those service policy rules to allow only traffic which should be allowed. So this is basically a simple demonstration, and we can not block just endpoint, but we can also block PII data, block the traffic, and much more. So if I jump back, the last slide, I'm not sure if Pranav is back or.
I'm back. Yeah, I'm back.
Okay, so maybe you can actually talk about this.
Okay, sure.
Close it.
Right. So as Jakub has gone through, right, the three key tenets that he talked about is discover your API, analyze your API, secure your API. The fourth tenet that users should look for in any solution for API or app-to-app security is, how do I deploy these apps anywhere, right? These policies anywhere. So all of the policies that Jakub showed in the previous slide is you need to be able to deploy the policies wherever your app or your API exists. Your app or API could exist on the cloud, so you need to deploy this in the cloud. Your app or API could exist on the developer's laptop because he or she is developing on the laptop and then pushing it to staging a production. In the whole shift left method of security is, how do you find and catch these APIs that are exposing PII data early? Maybe the developer does not even know that this is PII data, right? So by pushing these policies to the laptop, you can do that. And if you look, think back on the examples that were done for Samsung or Mercedes or even the gym apps, pushing the APIs onto the edge where the API has been exposed from the TV, from the car, from the robot, or from the gym device is what you should look for in any solution. Can you push to the next slide, Jakub? All right.
Yes.
So, and if you could build it out. So as we've summarized in this talk, to secure against modern apps, where it is characterized by app to app or API to API based security, the current tools are not designed to protect against this. The current tools, such as a web application firewall or a router or an API gateway, which are individual siloed point products, are not designed to work together to protect against the needs of modern applications, which is characterized by API to API and app to app communication. What is required is a integrated network and security stack that is focused on app to app and API to API security. And for any solution that users should look for to solve this app to app and API to API security, it should solve four key problems. One, allow you to discover communication between services and APIs, analyze the communication, tell you what data is being shared, tell you if it's PII. Third, provide an automated way to enforce the policies based on what you learn. And then fourth, this solution should be deployable anywhere, in the cloud, in the edge, in the network, anywhere where your app or API exists. Thank you. We can open it up for any questions if they are from the audience. I see one question from the audience. Jakub, maybe if you can, you spoke about how the Starbucks example could be solved. Can you talk about the dating app example where there was a PII data in the API response? How would that security policy, the pattern, be used to protect against that?
Yes, so basically in this example, what was happening is that there was API request and it replied with the password. So in this case, we would identify the password and we would identify it similar way as we did for the credit cards. So basically we would identify the pattern, and then by using service policy, we can actually block that pattern. So through machine learning, we get to know there are PI data, and then we can block them through service policy.
Okay. And then, so there's another question from the audience, Jakob. How are these, so you are an SRE, right? So how are these APIs actually getting into production? Is it that SRE does not know what APIs have been developed by the developers? Is that typical to expect in a large company?
Yeah, so many times what is actually happening is that they don't know what's the traffic, right? Because they are not involved in the developers. So what is really helpful here is you can actually learn it on the staging and see the differences and see what is changing, and then you can apply the same rules to the production without need of any manual change, because we are able to do it in a generic way. So this can be really helpful for such use cases.
Yakub, there's also a question from the audience from Prashant, where he talks about for an API to API security, shouldn't we design using service mesh, giving me more flexibility for user policies, and thereby eliminating the gateway? I think if Yakub, if you can just show show the UI again, this is using service mesh. It is using the
Yes.
API to API communication in the service mesh. I don't know if you can share your screen and actually show that.
Yeah, give me a sec.
It is the ingress controller, ingress gateway between the services, or which all the services are going through. It is essentially a service.
This one, right?
Yep.
So this is actually service mesh, service graph, which is showing which microservice talks to what microservice. So actually, just for people to better understand, these services are running inside of the Kubernetes. So here, if we check the deployment, you can see there are currency service, front-end service. So these are actually the microservices, like pods, which are running there. And this service mesh graph is actually showing the communication between those containers.
Right. In addition, Prashant, in case of, yes, you're right, we should use a service mesh, but note that service mesh, the applications could be running anywhere, right? You could have the front end running in the network, the cart service running in AWS, the checkout service running in Azure, or they could be in different in the private DC and so forth. In that case, your service mesh is not just within inside one cluster, is actually across multiple clusters, across multiple sites, locations, and clouds. And that is what Jakub was showing you, is your app has actually, modern applications are distributed, so you need to protect them at the right places. So it is service mesh, is where what Jakub showed, but it is service mesh where the apps are distributed across multiple clouds and the network. There's one more question, is how is this feature different? So Jakub, the question from the audience from Yasin, Abdallah, is how is this feature different from zero trust network?
Zero trust network. Good question. Pranav, can you answer this one?
Sure, yeah. Exactly. So yeah, so what is zero trust, right? So zero trust is you. So this obviously encompasses aspects of zero trust, which means you don't trust the caller. You're actually authenticating and authorizing every communication. So yes, this is doing that, but this is doing a lot more than that, because this is you need to think of multi-layer security, right? First is you need to protect against the network level communication, because this is going over the network. So for example, DDoS, right? You need to protect against that. So rate limiting, for example, that is not part of zero trust. That is essentially protecting so that you're not exposing your information. So in the gym app, the people who were doing 10,000 requests and were able to break the password reset, right? So you need to do rate limiting. Zero trust is obviously required because you need to authenticate and authorize every communication. But even above that is also the whole monitoring and observability. For example, learning of the APIs or learning the patterns, that is not part of zero trust. Zero trust comes after that, is securing it. But the whole analysis and discovering, that is what you need to look for in any solution. You need to look for all of these different patterns. You need someone to tell you, is this a PII data or not? Is this what data is being shared? Those are not included as part of zero trust as it is defined today, right? This is what you also need to add in your app to app communication. So Yakub, is another question that was asked is, who is the solution most useful for? Is it for developers? Is it for DevOps, SecOps? Like, who would use this information?
Yeah, so there are various roles. So actually, there are some, I would say, user stories or like flow which will be used by devs in case of, for instance, the virtual KTS, which is abstraction on top of Kubernetes, which allow through multi-tenancy and allow to give developers freedom using Kubernetes API, but still being like isolated and in the secure environment. It also gives DevOps ability to scale across the sites and automate the policies, and also for SecOps, where it gives them the ability to see what developers and DevOps people are doing, have full control, and have very easy way how to secure entire environment, all environments actually, like in case of multi-cloud, from one Vault console, from one console. So I think it can be consumed by different stakeholders inside of the company.
All right. Those are all the questions we had, and we're out of time. Drew and Naomi, I think that there are no more questions, so I will pass the ball to you.
Awesome. Thank you, Pranav. And we are at that hour mark. So with that being said, DZone would like to thank Pranav and Jakub for the phenomenal presentation that we just received. Additionally, DZone would also like to thank Volterra for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.